What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to have a look at parallel box and whisker plots. So this is just to compare two data sets to see if there's anything different in the distribution of the scores. We're already great at using the mean, median, mode, and range to tell if there's any difference, but these parallel box and whisker plots will tell us something about the distribution and the spread of that data that those basic measures of center won't be able to do. The best thing about this for you is that we don't need to learn any more skills. If you're already good at making these box and whisker plots, you will find this totally easy. The only thing that you have to do after you've created both of them on the same axis is just tell me what are the differences between them. Because we are looking at measures of spread, please make sure you focus on that in your answer. So we're talking about things like the interquartile range, the median, the overall range is even a good one, or the position of the quartiles. From there, you can talk about the skew and distribution really easily. If you get a question like this and are asked to compare the two and you start talking about the mean or the mode, that will be something that you can't actually work out just from the box and whisker plot. These distribution facts are the things that your teacher is asking for from this question, so make sure you focus on those. So let's say we have two classes and they've done a test. Each class has 9 students and the teachers want to compare their data. So all we've got to do is find the median and those two quartiles for that class A. Just by crossing off the top and the bottom, we find that 42 is the median of class A, and then we just have to do the exact same steps on both sides in order to find our quartiles. Quartile 1 is found between two 38s, so the quartile is 38, and then the upper quartile is found between the 46 and 47, so the quartile mark is 46.5. And again, it's really easy to find the minimum and maximum. We've got 36, 48, done. They're our 5 numbers. We've got to do the exact same thing for class B. Cross off the top and the bottoms, and we get that the median here is 44. Doing that for the quartile 1 and quartile 3, in between 28 and 32 is 30, so that's our quartile 1 mark. And then in between 48 and 49 is our quartile 3, which is going to be 48.5. Again, finding the minimum max is easy, 22 and 50, chuck them down. We've just found 10 points of data incredibly quickly, and you're more than halfway to getting full marks for this question. Now we've just got to put this on the same axis. So I've already put the information on there for you, but you just have to make sure that you spend some time including all of the data points that you need on a similar scale. So this one I'm going from 20 to 50. 50 was my top mark and 22 was my lowest. So just make sure you account for everything and take the time to set it out properly. That's where most of my students will lose their marks. All I've got to do is put those 5 marks down for class A and class B, and we're already really good at creating these two. Make sure you give yourself enough space and then label them. We've got class A and class B. If you don't do that, it's a silly way to drop a mark, but that is all we have to do. From here, you can see what the differences between these two data sets are. For example, in the top one, class B, we could talk about how there is a strong negative distribution. A lot of the marks there are up the top, and then the tail is going down to the negative marks. That's the opposite for class A. We would have a slight positive distribution on that one. So that's something that you could get a mark for if you are asked to compare and contrast these two data sets. Another thing you might be asked is, which class did better? This is a really hard question. The median for class B is actually higher. So the middle mark was higher, but the lowest mark was much lower in that class B than in class A. You could even look at something like the lowest quartile. We have 25% of the students getting lower than 30 in that class B, whereas the 25% in class A, the lowest 25%, is done really well. They've all got above 35. So you might say something that, maybe the top students from class B might perform better than the top students in class A, but the bottom of class A is much stronger. These kind of observations will get you marks when you have to do this. It's not strictly mathematical, but it's taking the analysis of these two that is the important skill. You have to specifically tell me what are the differences between these two things using numerical values, and that's what's really important. Thanks so much for watching this lesson, guys, and I'll see you later.